There's a big problem with dark energy, ladies and gentlemen. Or to be more precise, there's a big problem with general relativity, since the conception of dark energy that we have at the moment relies on something called negative pressure. And in physics, generally speaking, negative pressures occur when there's a pressure differential between two different regions. So you get the negative pressure when there's lower pressure in one area compared to another. You never get pressure that's lower than zero, or so I've been told by the internet. You just get pressure differentials between various regions of space, or between different regions that you're studying. So one reason why dark energy is thought to have negative pressure is because dark energy is thought to have a gravitational influence or a gravitational effect. And this comes down to the notion that via the stress energy tensor in the Einstein field equations, um, we would expect to find that the vacuum energy would have some gravitational influence, which I believe is totally wrong, totally incorrect. I don't believe that energy has any gravitational effect whatsoever. I believe that the gravitational effect, or the via a theory of quantum gravity that I've been developing, or via a conception of quantum gravity that I've been developing, um, I don't believe energy has any gravitational influence, since I don't believe in anything like the curvature and distortion of space-time in the background. I believe that electrons transmit the gravitational force between objects. So this occurs when, say, you have two hydrogen atoms, each of my fists being a hydrogen atom. An electron from one would tunnel to within the electroweak range of the proton in the other atom, and exert a force of attraction over that proton in the atom, pulling the two atoms together via exchanging W plus and minus particles with the nucleus of that atom. So you get a little force of attraction there between two atoms, because yeah, the exchange of electroweak particles. When it comes to dark energy, however, what I believe is really going on, I still believe that there's a negative pressure there in the way that physics defines negative pressure. As I've said already, it's just defined in terms of a pressure differential between two different regions of space. So when we're talking about this energy that's building up between galaxy clusters, I believe that that's just all the energy that's been building up there since the beginning of time, since the beginning of the universe. Think of all the stars, planets, galaxies, not planets, those don't emit light. Those reflect light, but nonetheless, stars generate light, obviously. Think of all the stars, yeah, in all the galaxies since the beginning of time, chucking out huge amounts of radiation. And what I also predict is that electron densities surround galaxy clusters, and these reflect light. So galaxy clusters reflect light, and we know that from general relativity anyway. They reflect light, and light builds up there between in these recesses of intergalactic space, and this drives accelerating expansion of the cosmos. So you get more light building up there over time, more radiation, and yes, it does come down to radiation pressure yet again, dark energy, the effects of dark energy, since it's just all the radiation there building up since the dawn of time, since the beginning of the universe, driving the expansion because it has nowhere else to go, is exerting pressure over the galaxy clusters themselves, forcing them apart, and it happens that over time this effect of being pushed apart is accelerating. And we know that the universe's expansion is accelerating. It's one of the biggest discoveries in cosmology in the last century. In the mid 1990s, I think that happened, with Adam Rees and a few other people. Perlmutter, I think it was also, who discovered the accelerating expansion of the cosmos. Two teams in cosmology working, um, or like competing with one another to discover that in the late 90s. Um, so yeah, it comes down to a big problem with general relativity. It comes down to a big problem with the stress energy tensor, and the fact that this tensor implies that dark energy, all this energy that's been building up there since the dawn of time, which would have been building up there anyway, let's not forget, since we know the galaxy clusters and stars have a reflective capacity. So there would still be energy getting reflected between galaxy clusters building up there. In any case, even with standard general relativity, it predicts that that energy in the background would have a gravitational effect, and hence you need dark energy You need to invoke dark energy to give negative pressure to those regions of space to explain the expanding cosmological, or to explain the expansion of space and the accelerating expansion of space, which I believe is totally wrong, total nonsense. But and it can be explained far more intuitively just by abandoning this idea that energy needs to have a gravitational influence or needs to have gravitational effects associated with it. Um, and I don't believe that's ever been proved in science that you can take a load of energy, a load of photons in a bag, say, that it will create a gravitational influence. I don't think that's ever been tested. Uh, and yeah, that doesn't hold up to much scrutiny, I don't think. It shouldn't do anyway. And if we take as the postulate via an updated conception of a theory of gravity that electrons transmit the force of gravity, then we can abandon that idea totally, have a far more intuitive understanding of the expansion of the universe, whereby it is just positive pressure, if anything, or a sort of negative pressure anyway, since the builds up of radiation between galaxies, galaxy clusters, um, wouldn't have as much pressure in it as the galaxy clusters themselves. So it would still be negative pressure. But yeah, and that would be driving accelerating expansion of the cosmos. And it's energy that we can't see because it's being trapped there. It's just bouncing around between galaxy clusters. It's not going in the direction of our telescopes. So it is still dark energy. It is still, and probably, yeah, it does make up about 95% or whatever it is. Or is it 68.7% of stuff in the universe? Since a huge amount of it would have been released since the dawn of time. And it's just sort of getting reflected between galaxy clusters rather than going in the direction of any instruments that we have in space, for instance, or on Earth in terms of radio telescopes and whatnot. And yeah, it's just bouncing around there between galaxy clusters. So there's lots of different approaches to dark energy, but none of them really kind of encapsulate, I think, what's really going on in the cosmos, what's really going on with cosmology. And yeah, it comes down to dogmatism, unfortunately, I'm afraid to say. It comes down to just considering the Einstein field equations sacrosanct and not being willing or able to question things like the stress energy tensor, not being willing or able to address these problems with the physicality of general relativity, and trying very, very hard and very, very contrived means of making everything fit in terms of cosmological models, invoking like lambda CDM models and trying to use the vacuum energy to explain the expansion of the universe and these particle-antiparticle pairs being spontaneously created and annihilated and all this stuff that I think is utter claptrap and rubbish. But yeah, and trying to use that to explain this stuff. But I think what's really going on is there's a problem with the stress energy tensor. I think it's unphysical, and I think the Einstein field equations take us a very long way with gravity. I'm not going to deny them that they've had stunning successes in terms of being able to predict all sorts of phenomena in nature. But because who would, right? Who would deny that? But I think there's fundamental problems with them. I think they take us 2 steps forward and 1 step back. I think with understanding nature, or take us some of the way, but not all the way. And we need to go further with an understanding of quantum gravity to be able to properly explain dark matter and dark energy, and have these open holes in our cosmological models because inconsistencies were imputed into the mathematics that govern physics of the present in the past, and we've inherited a legacy of error, basically. And really, what's driving the expansion of the cosmos is radiation pressure yet again, and it is just these recesses between galaxy clusters in intergalactic space, filling up there with radiation over billions of years and expanding, and the expansion accelerates as it happens. And by the way, predicting what will happen at the end of the universe when all the stars stop shining and so on, when all the stars go into supernova and the universe goes dark eventually, which it will eventually. The universe will just contract again, I predict, under the force of gravity, and we'll probably have a big bounce and another big bang. So you get rid of all this big rip stuff in cosmology that comes down to magical ideas such as creation and annihilation of particle-antiparticle pairs in the background with the vacuum energy, and nothing like that is going on, luckily. So we hopefully will have another era of cosmic collapse and another big bang again, and the whole thing will just start over again, continue going, which I'm pretty certain will happen. Thank you for watching, everybody. Bye bye. Love you lot.